Welcome you all for project management class. Today we are going to see about PERT. So last class we already see about PERT time estimate. So today we are going to see about PERT time computation. We are going to see about PERT time computation. So in this PERT time computation we have we have to see about two time estimates, that is earliest expected time. So the first is earliest, already have seen expected time. So here we are going to see earliest expected time. So earliest expected time denoted by TE. So we have already seen expected time denotes like small te. This is expected time. So this is capital TE is earliest expected time. So don't get confused about this both. We have expected time and time estimation. So in time computation we have earliest expected time. So what is earliest expected time is? The earliest expected time is the time when an event cannot be expected to occur. That is called as the earliest expected time. It is always represented by symbol capital T, capital E, and appears above or below the node. We have seen the network diagram, right? It always appears above or below of that each node. Node is an event. So earliest expected time TE is computed by adding the expected time. So TE is computed by adding a expected time, that is small TE, of all the activity along an activity's path leading to that event. If more than one activity path leads to that event, then the maximum of the sum of expected time along the various paths will give the earliest expected time. So coming to earliest expected time, so it is indicates like capital TE. It is the sum of expected time. So we have to add the expected time, and we have to take, always we have to take the maximum number. So that is called as the earliest expected time. So next is the latest allowable occurrence time. That is represented by TL. So this is latest allowable occurrence time. That is T, capital T, capital L. So latest allowable occurrence time is always the minimum number. So you have to take a minimum number. So this is latest allowable and earliest expected time. So I will be telling you the formula for TE. TE. Formula is TE plus TE IJ. So this is I, this is J. So this is the formula for earliest expected time. So I will give you one small example to understand this earliest expected time. Okay. So this is one basic network diagram. So they will be giving you this optimistic time, pessimistic time, most likely time. So same here, optimistic time, pessimistic time, most likely time. Optimistic time, pessimistic time, most likely time. So you will be calculating. So once your diagram is like this, you will be calculating expected time. Therefore, if you calculate expected time formula, this TE value will be 6. Here TE value will be 7.5. Here TE value will be 9.5. So as per your expected time formula, that is optimistic time, pessimistic time, most likely time. So if you use that formula, so I hope you all remember that formula. So using that formula, you will be calculating this. So next is we have to calculate, here we have to calculate TE, that is earlier expected time. So earlier expected time is TE, this formula. If you want to calculate for T, so earliest expected time, always it is indicate above or below to your node. So you can take above or below to your node. So you can write it above to your node. TE equal to 0 because this is start even, it does not have any earliest expected time. So before 1 we don't have anything. So always for 1 even we will be having earliest expected time is 0. Okay. So next we will be doing for 2. So if you take this 2, what is your TE? So what you will do, you will be calculating in the formula. That is TI. So this is your J. Okay, set consider this 2 is your J. So you will be taking I as per your formula. Take as per this formula. As per this formula, if you're doing for 2 event, what is your I? So I will be TEI will be this one. So you'll be doing 0 plus T small Tij is this 6. 0 plus 6, what is your even 6? Have you understood? If you are taking for 2, if you are taking for 2, your formula will be TI plus TIJ. So TI will be your this 0. So you'll be having before. So before your 2, what event you have, that event earliest expected time you will be taking. This is 0. So 0 plus 6. 6. What is 6? 6 over here is this one. TE equal to 6. So 0 plus 6 is 6. Have you understood? So this for earliest expected time here is 6. And here we got 0. Here TE equal to 6. So same. So same formula you will be applying over here. So if you take for this 3, applying your formula, so you will be applying you will be finding TEJ. So TEJ for 3, we have to find this. We have to find this. Our formula is TEI plus IJ. So if you take this, you have to see the before. What is your before event, before activity? So for TI, you will be taking, what is TI here? You will be taking this 6. So 7 point. So this TEIJ is 7.5. So 7.5. What is the value here? 6 plus 7.5 is 13.5. So 13.5 is your earliest expected time for even 3. So you will be writing T equal to 13.5. So T equal to 13.5 because the 6 plus, you have taken the 6 plus 7.5. So 6 is your TEI. So TEIJ is your 7.5. So 6 plus 7.5 is 13.5. So same point here. What you will take? You will see always the before what even you have 13 plus 5, 13.5 plus you will be taking 13.5 plus 9.5. So 13 point plus 5, 9.5, how much? 23. So this is how you have to calculate the earliest expected time. Have you understood how to calculate the earliest expected time? So earliest expected time always it will you have to write it down about to your node. So about to your node. So this is your node. So you'll be writing about your node. That is capital TE. So always you have to consider if you want to calculate earliest expected time for one, you will be seeing before what activity you have. It doesn't have any activity. So you will be writing directly 0. So for this thing. If you want to calculate for, you will be calculating for each event. So for 2 event, if you want to calculate, you will be seeing the before which activity you have. This 1 to 2. So this activity will be have. You have to calculate for this. So 0 plus 6 is 6. So for 3, you will be calculating the before what activity you have. 7 plus 6 plus 7.5. Next is the 13 plus 9.5 is your 23. You should have a maximum number. So next I'll be giving you one more thing. Next is the your next is the latest allowable occurrence time. That is TL. How to calculate TL? So we have seen expected time, earliest expected time. Now we will be seeing the latest allowable occurrence time. That is the formula is TL I equal to TLJ minus TEIJ. So this is your earliest expected time formula. So this formula is all important. It will be asked in your 1 mark question. So this is your minus. So you can see the difference between the earliest expected time formula and latest allowable occurrence time formula. So these are the two formulas and this is like L. Latest allowable means L. Earliest expected means E. So that in that formula you will be having plus symbol here minus. So this is the main difference you have. So I will be giving you the same example over here. So this is the formula. I will give you one small example. Three, four. So this is your network diagram. So they will be giving you T E 6. That is expected time 6. 7.5. 9.5. So they have given you the if you want to find latest allowable time, you have to know what is your expected time, what is your earliest expected time. So then only you can find your latest allowable occurrence time. So here you have to know what is TE. For everything you have to calculate the TE. That is earliest expected time. So we have calculated already, no? The same example we have seen for your. So for 1, you will be always having the 0. For 2, 0 plus 6 is 6. So for 3, 6 plus 7.5 is 13.5. So for 13.5 plus 9.5 is 23. So this is your earliest expected time. So now you will be indicating, now you will be calculating latest allowable occurrence time. Same. So that is also can be indicated below to your node. So that is TL. You have to find TL. You have to find TL. You have to find TL. You have to find. So always for end event, for last event, you have to take earliest allowable time as same earliest expected time. So same time you will be taking. So from here you will be minusing, you will be minimizing everything. So next is the 23. So you will be from 23. So apply this formula. P apply the formula here. So this is your I. What is TLJ over here? So this is your I. This is your J here. Okay. So I, J. This is your I. This is your J. So as per your formula, you will be finding for TL. For this only for this node we will be finding. So what is your this 23 minus 9.5. So 23 minus 9.5 is 13.5. So next, so here this is your I, this is your J. So 13.5 minus 7.5, that is your 6. So here if you come, this is your I, this is your J. Then 6 minus 6 is 0. So this is how you have to reduce the, you have to do minus, here you have to do plus. Here you have to do plus, 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 then you have to do minus, minus, minus. So this is how you have to apply the TL formula. Now I have given you example for latest allowable time, same like earliest expected time. So these are the two examples. Okay. So you know what is the earliest expected time, what is the latest allowable occurrence time, and expected time. So these three you are clear about that, I hope. So note down the formulas. Formulas are very important. And if you see time computation, you have two techniques. So that is earliest time and expected time. These are the two techniques you have in time computation. So the formula is same thing which I have given. So are you all clear? Shall we move to one small problem?